I hope you guys are ready for today's lesson. Okay. So today, the subtopic that we are going to learn is the continuation from our last subtopic. It is still in chapter 6, and we are going to talk about salt. Okay. There are still acid and bases here as well, but the main thing is salts. And we are going into 6.9, subtopic 6.9, preparation of salts. Okay, let's go. So this is the learning standard for this subtopic. There are 4 things that you should know from this subtopic. It's quite a long subtopic. So in today's class, we are going to cater this point and half of this point. Okay, we are going to test the solubility of salt in water and classify them into soluble and insoluble salt. Okay, you are going to classify them into soluble and insoluble salt through experiment. Okay, sepatutnya kita buat eksperimen, but we are going into theory first today. Okay, and I'll see if we have videos from MRSM channel that I can share with you guys after this. Okay. Next one, we are going to describe the preparation of soluble salt. There are 4 ways. Okay, generally 4 ways to prepare soluble salt. We are going to look at the first ways first. Okay, cara yang pertama sahaja. So that is what we are going to learn today. Okay, next. So first, we are going to the first one, the solubility of salts in water. You should know which salt are soluble salt and which salt are insoluble salt. And you should memorize them. Okay, that should you first classify soluble and insoluble. Okay, and then memorize. That is what you need to do in this learning outcome number 1. Okay. Okay. So you should do the activity to classify between soluble and insoluble salt, but since we are still in PDPR, so we will go through the procedure and we will just go, kita boleh terus classify lah based on the supposed results. Okay, so in order to test, okay, the aim is to investigate the solubility of various salt in water. Kita dah belajar there are so many type of salts. Okay, we have nitrate salts, chloride salts, carbonate salts. Okay. What else? Sulfate salt. Okay, kita ada, yes, all those salts. Okay, kemudian kita akan test whether those salts soluble or not in water. So the problem statement is, do all salts dissolve in water? And our hypothesis are, it is some salt dissolve in water while some salts does not dissolve in water. So the manipulated variable would be the type of nitrate salt, sulfate, chloride, carbonate and ammonium salt. Okay, semua salt yang ada yang kita nak test. The responding variable would be the solubility of salt in water. The fixed variable is the volume and temperature of water and the mass of salt. Kita nak guna mass of salt yang sama lah. Temperature dan juga volume of water yang sama. So that dia tak akan mengganggu. Kalau air sikit sangat, nanti kalau garam ni banyak dia tak larut, tapi sebenarnya dia larut. Okay, so kita kena fixkan those variables. So the procedure sangatlah senang. You just weigh the salt using electronic balance. Okay, tulislah berapa gram of salt using electronic balance, and then you add distilled water into transfer the salt into a beaker, and then you add distilled water. Okay, the fixed volume of distilled water kan, volume must be fixed. Let's say you add 25 cm³ of distilled water, and then you stir the salt. Okay, until ikan sampailah dia macam dah tak boleh, no change, dah tak ada perubahan lagi dah. And then you record the result. Senang saja. Okay, sebab awak hanya campur air. Timbang berat yang sama, measure air yang sama, campurkan, stir, and then you can see the result. Ingat, temperature of the water must be sama juga. So that is how you test solubility of salt in water. So apa yang dimaksudkan dengan soluble salt? What are meant by soluble salt and what are meant by insoluble salt? Okay, so soluble salts are salts that dissolve in water at room temperature. Meaning kalau dekat room temperature, water tu at room temperature, kita letak salt and then they dissolve, itu they are considered as soluble salt. While non-soluble salts are salts that do not dissolve in water at room temperature. Okay, kita bubuh air at room temperature dekat the salt, kita kacau, stir, dia tak soluble, dia tak dissolve. So we call the salt as non-soluble salt. So bila when you do the activity, supposedly you will get these results. Okay. So type of salt, selalunya kita akan bahagikan type of salts into these 4 category. 4 or 5? 5. 1, 2, 3, 4, 5. 5 category. Okay. So nitrate salts, okay, as usual, comes from what acid? Do you still remember? Yesterday we learned, last 2 days, nitrate salt comes from which acid?
Nitric acid.
Nitric acid. Good. How about sulfate salt?
Sulfuric acid.
Sulfuric acid. Good. How about carbonate salt? Carbonate salt.
Carbonic acid.
Yes, carbonic acid. Chloride salt?
Chloric acid.
Hydrochloric acid. Suka hati je. Hydrochloric acid. Okay. Well, this one, ammonium, sodium, and potassium salt, we usually call them as anak salt. Anak salt. A is for ammonium. Ammonium. And A is sodium, while K is potassium. So these 3 salts are special, sebab tu kita ada dia different group. Okay? So this is this is the supposed result that you should get. So when you put all nitrate salt, tak kisahlah apa-apa nitrate salt, meaning, cuba bagi example. Okay, write down 1 nitrate salt in the chat box. Write down one nitrate salt. This is your participation marks. I want 5 nitrate salts. Sebelum kita proceed. 5 people. What are example of nitrate salt? Zinc nitrate, good. Another one. Sodium nitrate, good. Lead 2 nitrate, good. Another 2. Ammonium nitrate, good. Calcium nitrate, good. Thank you. Silver nitrate, good. Alright, so all those nitrate salt, as long as it has nitrate ions in there, okay, so we call them as nitrate salt. So all of them, okay, when we use nitrate salt and we add water, all of them soluble in water. All of them soluble. Every nitrate salt are soluble in water. Is there any nitrate salt that are insoluble in water? No. Okay, all nitrate salt are soluble in water. Okay, sulfate salt. Okay, sulfate salt also soluble in water, but most of them, okay, most of them soluble in water, except we have 3 exceptions. Okay, we have 3 exceptions. So these 3, lead sulfate, lead 2 sulfate, barium sulfate, and calcium sulfate are insoluble in water. Okay, so if I ask you, okay, does zinc sulfate soluble in water or not? Zinc sulfate soluble in water or not?
Yes.
Yes, good. Because zinc sulfate is not in here. Okay. So other than lead 2 sulfate, barium sulfate and calcium sulfate, all sulfate salts dissolve in water ataupun dikenali sebagai soluble salts. Clear?
Yes.
Okay, good.
Yes, teacher.
The same goes with chloride salt. All chloride salts except for mercury chloride, lead 2 chloride and silver chloride, okay, all of them except for these three, all of them are soluble in water. Okay, all of them are soluble in water except for mercury chloride, lead 2 chloride and silver chloride. Okay, other than that semuanya soluble. Okay, so chloride dengan sulfate ni lebih kurang sama. Everything soluble except there are 3 exception. 3 exception and 3 exception. But it is different with carbonate salt. Okay, carbonate salt, most of it are insoluble. Most of it are insoluble. Except for sodium, potassium and ammonium carbonate. They are soluble in water. Okay, yang lain tu semua insoluble. And the last one is ammonium, sodium and potassium. Okay, if you notice, this 4 is the anion. Bahagian belakang dia, anion. So, kalau anion dia nitrate, dia nitrate salt. Kalau anion dia sulfate, dia sulfate salt. Kalau anion dia chloride, dia chloride salt. Kalau anion dia carbonate, dia carbonate salt. Okay, but this one is cation. Okay, kalau salt tu ada cation ammonium, cation sodium and cation potassium, okay, dia ada kelas sendiri. Why? Because all of ammonium, sodium and potassium salt are soluble. Tak ada yang insoluble. Kalau the cation started with ammonium or sodium or potassium, tak kisahlah dia nitrate, sulfate, chloride or carbonate kat belakang dia, bila hadapan dia, cation dia adalah ammonium, sodium or potassium, tak kisah langsung belakang dia apa, everything is soluble. Okay, everything is soluble. Other than these 3, selain daripada 3 benda ni, dia kena tengok bahagian belakang dia. Nitrate salt, sulfate salt, chloride salt or carbonate salt. Okay? Boleh faham? Is it clear?
Yes.
Yes.
Any questions here? Any questions here?
No.
Alright,
No.
so let's proceed. Okay, so you have to memorize the solubility of salt in water. Okay, in your textbook, they have given you some formula that you can use. Okay, the first one using mnemonics method. So dia cakap all no asap salt dissolve in water. PBC sulfates and HPA chlorides do not dissolve in water. So no asap adalah nitrate salt. Asap is ammonium, sodium and potassium salt. So all of them soluble in water. Okay. PCB sulfates and HPA chloride does not dissolve in water. PCB ni apa? Lead, barium and calcium sulfate, mercury, lead and silver chloride are not dissolved in water ataupun insoluble. You can use this one, or you can do your own formula, or you can use this one. First, you draw a big droplet of water. Okay. And then we have nitrate. We have sulfate. We have chloride. And we have carbonate. Okay, if you draw it like this, okay, ingat droplet of water, and then you write down all the anion. Okay, cumanya 3 dekat dalam, carbonate di luar. Okay, and then you remember PCB, taklah PCB, pantai cahaya bulan, or called as PCB, and cepah. Okay, so ini maksudnya P, lead, calcium, and barium. This one is lead, silver, mercury. C is chloride, chloride, chloride. So bila chloride, so letaklah kat sini C, PAH, PAH. Sulfate, PCB. PCB. B. Chloride, carbonate, sorry, anak. Okay, anak. Lead, calcium, barium. Lead, silver, mercury. Okay, kalau buat this diagram, so you will know that apa-apa pun nitrate salt, semuanya dalam water, dissolve. Sulfate salt, semua dissolve in water except for lead, chloride, barium. Chloride salt, semua dissolve except for lead, silver, mercury. Carbonate salt, semua insoluble except sodium, ammonium, sodium, and potassium. Okay, whichever ways that you want to do, it is depends on you. As long as you can remember which salt is soluble and which salt is insoluble. Boleh?
Boleh.
Alright.
Boleh.
Good. Next one. There are some special case. Okay. Dah cakap tadi, non-soluble salts are salt that does not dissolve in room temperature. But there are two salts. Okay. Lead chloride and lead 2 chloride and lead 2 iodide are specials. They're insoluble in water. Okay, they are insoluble in water. Sebab apa? Sebab dia chloride kan? Chloride dengan iodide, lead iodide dengan lead chloride, they are insoluble in water, but they can be dissolved in hot water to produce colourless solution. Kemudian bila water tu dah jadi cool balik at room temperature, the solids are reformed. Dia insoluble balik. Contoh, lead chloride, warna dia white. White lead chloride. Kita letak, kalau kita buat eksperimen tadi, kita letak distill water biasa saja, dia insoluble. But when we add hot water, they dissolve. Okay, dan jadi colourless solution. Kemudian when the water is cool, white solid form again. Lead 2 iodide, dia warna yellow. Lead 2 iodide, kalau kita buat eksperimen tadi, kita add je distilled water at room temperature, dia insoluble. Okay, but then when we add hot water, they dissolve dan jadi colourless solution. Dia tak jadi air colour kuning, dia jadi colourless solution. Okay, and then bila the water is cool, yellow solid is formed again. Dua ni sahaja yang special. So, quick recap. Lead 2 chloride dengan lead 2 iodide, they are classified into soluble or insoluble salt.
Soluble.
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 Lead 2 chloride and lead 2 iodide are soluble or insoluble?
Insoluble.
Okay. The answer is they are still considered. Okay, jap. No. Tak nak bagi answer lagi. Why do you say it is soluble tadi? Wolfstead, why do you say it is soluble? Wolfstead?
Because it in an organic compound.
Kenapa organic compound pula? Kita tak cakap pasal organic compound pun dekat dalam solubility of salts ni. Ni semua kita dah belajar tadi. Semua salt are in ionic compound. Bila ionic compound? Because it can dissolve in hot water. Ainul cakap because it can dissolve in hot water. Sebab tu, you said, so Ainul kata dia insoluble. Betul Ainul? Ainul said it is insoluble because it can dissolve in hot water. Okay, the answer is, they are considered insoluble. Betul Ainul cakap. Why? Because it can dissolve in hot water. Betul juga. Sebab kalau kita tengok, the meaning of soluble salt adalah salt that dissolve in water at room temperature. Okay, so here, which water is at room temperature? Which one? Belah kiri atau belah kanan?
Kanan.
Belah kanan.
Kanan.
Bila dekat sebelah kanan, the salt dissolve or not?
Not. No.
No. So bila does not dissolve, they are considered as soluble or insoluble salt?
Insoluble.
Insoluble. So the answer is they are insoluble salt. Cumanya when the water are being heated ataupun when we add hot water, barulah dia dissolve. Tapi dia still considered as insoluble salt ataupun non-soluble salt. So when the question asks you to classify lead chloride dengan lead iodide, where should we put lead chloride and lead iodide? Soluble or insoluble?
Insoluble.
Insoluble. Okay, dua tu sahaja yang special. Yang lain tak ada nak dissolve kalau dia insoluble. Okay, clear?
Clear.
Clear?
Yeah.
How about others? Clear as well?
Clear. Yes.
Okay, so can we move on?
Yes.
Alright. Now we are going to see the preparation of salt, the next subtopic. Okay, the preparation of salt. So the preparation of salt adalah cara untuk kita menyediakan salt tersebut. Okay, we have 5 groups of salt kan? We have nitrate salt. We have chloride salt. We have sulfate salt. We have carbonate salt. And we have anak salt. Anak is ammonium, sodium and potassium salt. So 5 kumpulan ni. Okay. These 5 groups, okay, boleh dibahagikan juga kepada soluble salt and insoluble salt. So, the method to prepare salts depends on the solubility of the salt. So, kalau kita nak prepare, let's say let's say kita nak prepare one type of salt. Okay, first thing first, we have to know whether it is soluble or insoluble salt. Okay, and the type of the salt required. Kemudian kita tengok either dia soluble atau insoluble. Kemudian dia nitrate salt, chloride salt, sulfate salt, carbonate salt or anak salt. Okay, because it depends on the solubility. Kalau dia soluble, there are 2 ways untuk prepare. Macam tu. Kalau dia insoluble, ada 1 way to prepare. So today, Sekejap saya cakap pasal ni dulu. So soluble salt pula boleh dibahagikan kepada dua. Okay, soluble salt can be divided into ammonium, sodium and potassium salt. This one. All ammonium, sodium and potassium salt are soluble, right? So the way to prepare them are using neutralization between acid and alkali. Acid and alkali. Selain daripada ammonium, sodium and potassium salt yang soluble, let's say lead 2 nitrate, let's say zinc chloride, let's say zinc sulfate. Okay, they have, untuk prepare soluble salt itu ada 3 cara. Okay, 3 cara bergantung kepada depends on the type of the salt. Okay, nanti kita akan tengok. So which ways yang kita boleh guna? There are 3 ways. Okay, tapi sebenarnya cara tu sama sahaja. Cumanya apa yang kita reactkan je. First one is acid react with reactive metal. Ataupun kita nak reactkan acid tu dengan metal oxide. Ataupun kita nak reactkan acid tu dengan metal carbonate. Okay, alright. So today we are going to see this one first. Cara yang ini dulu. How to prepare sodium, ammonium, sodium and potassium soluble salt. Okay, kita akan tengok cara itu sahaja. So, we are going to preparation of soluble salt. Teacher, kalau sodium ethanoate dia tak soluble ke? Ethanoate. Sodium ethanoate. Ethanoate salt sebenarnya dia tak ada dalam, dia tak, awak tak perlu classify ethanoate salt. Tapi selalunya, apa tu soalan tadi? Sodium ethanoate. Sodium salt selalunya, all sodium salt are soluble. So, sepatutnya sodium ethanoate tu soluble lah. Okay. So, kalau belakang dia awak tak tahu, tapi depan dia adalah sodium, ammonium or potassium, they are all soluble. Okay. So, preparation of soluble salt, kita tahu bahawa there are 2 type of soluble salt. Sama ada soluble salt tu ada ammonium ion dalam dia, sodium ion dalam dia ataupun potassium ion dalam dia. So kita kena guna cara yang pertama. Kalau dia tak ada ammonium ion, sodium ion or potassium ion dalam dia tapi dia soluble, kita kena guna cara yang B. Okay, so today, hari ini kita hanya tengok cara yang pertama saja. Kita nak prepare, we want to prepare all, kita nak prepare any ammonium, sodium ataupun potassium salt because they are all soluble. So there are only one way to prepare anak salt, or we call this as anak salt. Why anak? This is ammonium, this is sodium, this is potassium. Okay, so we call this as anak salt. This is non-anak salt. Senang sikit. Okay. This is anak salt yang of course soluble. This is non-anak salt yang soluble. Kita kena guna cara B. But today kita nak tengok cara A dahulu. Okay, kita nak prepare anak salt. So anak salt kita prepare menggunakan neutralization reaction between acid and alkali, and the setup will be like this. Titration methods macam yang kita dah belajar before. Okay, so preparation of soluble ammonium, sodium and potassium salt, or we call as anak salt, mesti menggunakan neutralization reaction between acid plus alkali. So you will get salt, okay, which are soluble lah, soluble, plus what are another product? Water, good. Okay. So ini adalah reaction yang akan berlaku. So aim to prepare soluble salt through a neutralization reaction between acid and alkali. So mestilah material dia ada hydrochloric acid, ada alkali, ada acid, ada alkali, ada phenolphthalein, filter paper, distilled water. The apparatus adalah apparatus yang diperlukan untuk buat titration process. So kena ada beaker, ada glass rod, filter funnel, retort stand with clamp, pipette, pipette filler, burette, evaporating dish, Bunsen burner, pipe clay triangle, conical flask, tripod stand, white tile, and wash bottle. Kita tengok satu per satu. Okay, so the preparation of soluble salt, the first one, benda yang sama macam titration methods. Okay, you rinse pipette dengan small amount of alkali, kemudian kita buang yang kita rinse tu, and then kita pipette 25 cm3 of potassium hydroxide solution dan transfer dalam conical flask. Okay, so dalam tu ada 25 cm3 of potassium hydroxide solution ataupun alkali kita transferkan dalam conical flask, kemudian kita add few drop of phenolphthalein. Kemudian kita swirl untuk jadikan warna dia uniform. Kemudian kita rinse pula burette. Rinse burette dengan apa yang kita nak masukkan burette. Dalam burette kita nak masukkan hydrochloric acid. So kita rinse dengan hydrochloric acid. And then kita fillkan burette tersebut. Clampkan dekat retort stand dan record initial reading. Masih lagi. Okay. And then kita pun dah set up macam ni. Kita pun add lah acid. Add acid drop by drop. Slowly while swirl kat bawah tu. Continue adding until the colour of the solution change from pink to colourless. So what does this mean, pink to colourless? Meaning? Maksudnya apa?
Dari pink ke tak berwarna.
Yes, dari pink ke tak berwarna. What does that mean? Apakah yang dimaksudkan? Kenapa berlaku perubahan pink to colourless tu? What happened actually?
The neutralization.
Yes, neutralization are complete. Okay, kita cakap the neutralization are complete ataupun the solution dah neutral. Oh. Neutralization are complete ataupun dia dah jadi neutral. The solution dah jadi neutral. Kan mula-mula dia alkali, kemudian dia dah tukar jadi colourless. So meaning it is now neutral. Maksudnya neutralization dah complete. Dia dah reach apa point? Point apa nama dia?
Endpoint.
Good. Dia dah reach endpoint. Good. So, bila dah reach endpoint, kita pun record lah final reading of the burette. Kita record lah, oh rupanya 20 cm3 je of hydrochloric acid yang diperlukan. Okay, so required. So kemudian kita carilah volume tu berapa kan. So kita pun tengok, oh 20. So V tu 20 lah. Let's say V tu tak tahu. Kemudian kita buat. Awak ambil initial tolak final tadi, awak dapat 20 cm3. So now you know that you need 20 cm3 of hydrochloric acid. So apa nak buat? Barulah boleh mula neutralization awak again. Why? Sebab tadi kita nak determine the volume dulu. Now bila kita dah tahu volume, baru kita buat balik kembali neutralization process. Okay, sebab tu awak akan refill balik a new 25 cm3 of potassium hydroxide dalam a new conical flask lah. Tapi this time without phenolphthalein. Okay? Why do you think kenapa dah tak kena letak phenolphthalein dah dalam ni? Jeng. Siapa tahu? Kenapa tak kena letak phenolphthalein dalam ni?
Sebab memang dah neutral.
No, it's not neutral. Dalam tu masih lagi alkali. Kita baru nak buat neutralization. Kenapa tak kena letak phenolphthalein? Kita nak buat balik eksperimen yang sama. Kita nak masukkan balik asid ke dalam alkali. Tapi kita tak letak phenolphthalein. Why?
Sebab warna dia tak payah tukar.
Sebab warna dia tak payah tukar. Not really. Siapa lagi tahu?
Because the volume of acid kita dah tahu dia akan neutralize with alkali.
Exactly. Good one. Okay. Betul. Tepat sekali. Kenapa? Sebab the first one, kita letak phenolphthalein dalam tu sebab kita nak tahu bila dia bertukar jadi neutral. Sebab kita nak tahu berapa bilang volume of acid needed. Okay. So now, kan lepas proses step yang ke-8 tadi, you already know the volume of acid needed. So you do it again, but right now without phenolphthalein, sebab you already know that you just need 20 cm3 of acid. Sebab tu, lepas awak dah letak potassium chloride solution dalam conical flask, awak hanya tambah yang ni tadi 20 cm3 of hydrochloric acid dalam burette. Daripada burette ke conical flask. So awak tambah terus exactly 20 cm3 sebab right now you already know the volume needed to neutralize the potassium chloride solution. Okay? So dah neutralize lah. Boleh faham?
Boleh.
Okay.
Boleh.
So now, apa yang ada dekat dalam kita punya conical flask? Bila kita dah addkan our potassium hydroxide dengan hydrochloric acid, apa yang ada dekat dalam kita punya conical flask right now?
Potassium chloride.
Potassium chloride and
Water.
water. Good one. So potassium chloride and water lah ada dalam ni. Kalau dekat atas tadi ada phenolphthalein sekali, kita tak nak. Okay, kita tak nak phenolphthalein dalam tu. Why? Because kita nak prepare salt. Kita tak nak salt kita bercampur dengan phenolphthalein. Clear tak penggunaan phenolphthalein dalam ni?
Clear.
Clear So bila kita nak prepare salt, kita tak naklah dia bercampur our salt ni tadi bercampur dengan phenolphthalein. Tak nak. Tak nak. So sebab tu kita buat dulu yang first, ambil dulu volume yang diperlukan, buat balik supaya kita dapat our salt and our water. Okay? So because this is soluble salt, awak nampak tak ada dalam conical flask awak tu? Awak nampak ke ada salt?
Nampak.
Awak nampak salt dalam tu?
No,
Why can't you see your salt?
because it already bercampur
Because-
dengan water.
Yes, because it is soluble in water. Dia dah jadi soluble water. Dia dah jadi salt tu dah dissolve dalam water awak. Dia dah bercampur. Ingat balik, our aim is to prepare salt. So sekarang ni awak nak salt awak tu dalam bentuk kristal. So that is why kita kena buat this step. Okay? So we know that this dalam ni ada potassium chloride plus water. Now kita nak asingkan water, kita nak potassium chloride sahaja. So this is what we are going to do. Next one. Baru kita buat step nombor 11. So lepas kita dah dapat tadi dalam conical flask kita ada potassium chloride and water, kita akan pour the content into an evaporating dish. This is evaporating dish lah. Okay, bila kita guna evaporating dish, kita akan guna pipe clay triangle. Kita tak guna wire gauze, okay? Pipe clay triangle. Kita set up this setup. Kemudian kita akan heat the solution slowly to evaporate the water. Supaya water keluar, escape as gas. Okay, so that saturated solution is obtained. Saturated ni solution yang pekat. Okay, so next, how to know? How to know whether the salt is saturated or not? Waktu awak buat eksperimen tu, awak pun panaskan lah. Kemudian awak katain cikgu, cikgu, ni dah saturated ke belum? Ni dah saturated ke belum? I won't be answering that question. Why? Because you can know whether it is saturated or not by using this trick. You will dip a glass rod into the solution and then remove the glass rod. Awak dipkan sikit, okay, dip, tik. Kemudian awak angkat awak punya glass rod. Okay, if crystal are produced, maksudnya the saturated solution has been obtained. Bila awak angkat je, ada kristal kat ujung. Meaning dia dah saturated. Tapi bila awak angkat, dia masih lagi menitis-nitis air, maksudnya itu masih lagi belum saturated. Clear tak?
Oh, kalau dah jadi, kita angkat dia jadi solid kot.
Kalau kita angkat dia jadi solid, maksudnya dia dah saturated, dia dah pekat. Sebab air dah banyak keluar. Air dah banyak meninggal, dah evaporated. Boleh faham?
Boleh, teacher.
Okay, so now kita ada mission ni. Kita nak dapatkan potassium chloride. Okay, so kita dah keluarkan sebanyak mungkin air menggunakan bila kita heatkan dia until saturated. Now, what should we do? Okay, kemudian kita let the saturated solution to cool down. Bila awak dah cakap, oh cikgu, saya dah panaskan, dah saturated ni cikgu. Jadi what should you do? You let the saturated solution cool down. Maksudnya awak alihkanlah bangsa benda, no more bangsa benda bawah ni. Bagi dia cool down. Bila awak cool down kan dia, lama kelamaan awak akan nampak crystallization occur. Awak akan nampak potassium chloride crystal form dekat bahagian bawah tu. It might take a little longer. Dia mungkin akan bergantung kepada dia mungkin akan mengambil masa yang panjang, bergantung kepada salt, okay, dan bergantung pada volume of salt yang kita nak hasilkan, okay. Mungkin sehari, mungkin 2 hari, mungkin beberapa jam, but you should be able to see the crystal after you let it cool, okay. And then selepas dah jadi crystal, ingat balik kita punya aim, kita nak dapatkan potassium chloride tu kan. So kita tak bolehlah biar macam tu je. So what should you do? Awak akan filter the contents of the evaporating dish to obtain potassium chloride crystal. Kita nak potassium chloride crystal sahaja. Kita tak nak water tu dah. So kita pun filter. Filter lah sebab kita nak ini. Kita nak ni sahaja. Tapi kita akan rinsekan crystal tu dengan little amount of distilled water. Kita masih kena rinsekan tapi guna sikit je amount of distilled water. Siapa boleh bagi tahu saya kenapa kita guna sikit je distilled water untuk rinse?
Supaya dia tak jadi liquid lagi.
Betul, that's right. Okay, supaya dia tak dissolve balik dalam water tu. Nanti susah-susah awak kumpul kristal, tiba-tiba dia jadi balik. Dia dissolve balik dalam water. Tak nak. We don't want that. Okay, that's why kita guna little amount of distilled water sahaja. Good job. Okay, so gunalah sedikit sahaja water tapi awak still kena rinse crystal tersebut. Kemudian bila dah rinse, dah filter, okay, awak akan drykan salt tersebut. Awak akan drykan the salt crystal. Macam mana cara awak nak drykan dia? Awak tiup guna mulut? No. Awak akan drykan dia by pressing them between 2 pieces of filter paper macam dalam ni. So awak akan ambil ni kan awak letak dalam filter paper kan, dalam filter panel. So awak ambil filter paper tu, ambil another filter paper, awak press, okay, so that awak dapat keringkan potassium chloride crystal tu, dan awak akan dapat potassium chloride crystal yang dry. So this is what we want to prepare. And this is how we prepare salt yang soluble tapi dia ada ammonium, sodium and potassium dalam tu. So ammonium, sodium and potassium salt ini adalah cara untuk kita prepare dia. Okay? Boleh faham?
Boleh ke?
Boleh.
Good. So discussion, why is phenolphthalein needed? Okay, ni kita dah jawab tadi. Kenapa first one guna phenolphthalein, second one tak guna phenolphthalein, kita dah jawab. Why should not phenolphthalein indicator be added? Ni pun kita dah jawab. Yang pertama tadi, kita bubuh dalam titration yang pertama to know the volume of acid needed. Kemudian, kita tak guna dah balik dalam titration yang kedua because we already knew the volume of acid needed. And kita tak nak phenolphthalein kita bercampur dengan kita punya salt yang kita nak prepare tadi. Explain why the resulting crystal can only be rinsed with little amount of distilled water. Pun kita dah jawab tadi. Write a balanced chemical equation. Okay, balanced chemical equation. Potassium hydroxide plus dengan acid apa tadi? Hydrochloric acid. And our salt is potassium chloride. And our byproduct is water. Does this already balanced or not?
Yes.
Already balanced. Good. Sebab this is, kita tahu potassium 1 plus hydroxide 1, hydrogen 1, chloride pun 1. So bila semua sama charge, so automatic everything is balanced. So this is the balanced chemical equation. Give 2 other types of soluble salts that can be prepared by this method. Boleh bagi tak? Okay, everyone now write down the name of the salt that we can prepare using this method. Everyone, put it in the Google Meet. chat box. Tulis kat situ, that will be considered as your participation marks. We are at the end of our class today. Come on, I want to see some answers. Apa lagi? Okay, so this time, dalam eksperimen ni kita prepare potassium chloride salt. What are other salt yang kita boleh prepare using this method? Ammonium nitrate, good. Sodium salt, tak, it is not specific, Nathaniel. I want a specific name of salt. Sodium nitrate, good. Potassium nitrate, good one. Nathaniel, I want the name of the salt, not the group or type of salt. Danish, calcium nitrate. Okay, Danish. Calcium nitrate, the cation is calcium. So not in this, it is not anak salt. Okay. Potassium carbonate, good. Sodium chloride, good. Ammonium nitrate, sodium sulfate, good. Okay, Danish, another one. Can you give another example? Potassium nitrate, good. Potassium nitrate, okay, boleh sama. Sodium chloride can as well. Sodium, Frankie Tegong. Sodium carbonate can as well, Danish. Okay, good. As long as the front of your salt is named sodium, potassium or ammonium, okay, as long as your salt sekarang ni nama dia kat depan adalah sodium, potassium or ammonium, semuanya menggunakan this type of ways. Okay, good. Ammonium chloride, good, Chelsea. Okay, so everything ammonium, sodium or potassium salt, awak kena prepare using neutralization reaction between acid and alkali. Okay, other salt macam yang contoh yang Danish cakap tadi kan, calcium nitrate salt. Okay, dia tak ada ammonium, potassium and ammonium, sodium and potassium dalam tu. So we cannot use this one. We don't use this titration method or neutralization between acid and alkali. Kita akan guna this part pula. Okay, not ammonium, sodium or potassium salt. Okay, dia tak ada ammonium, potassium or sodium, tapi dia soluble. Okay, macam yang Dennis cakap tadi, calcium nitrate. So kita tak guna cara ni, kita akan guna this part. Sama ada cara 1, 2 or 3. This one we will see. Kita akan tengok pula nak guna cara macam mana or how to prepare this soluble salt in our next class. Okay, so until today I hope you understand that you have to know. Kita recap balik what do you need to know. So you have to know the meaning of soluble salt and meaning of insoluble salt. And then you have to memorize the name of the salt that are soluble in water and insoluble in water. And then today we also look at the preparation of soluble salt. Okay, part 1 iaitu preparation of soluble salt which are anak salt, which are ammonium, sodium and potassium salt. Okay, so this is the one yang kita dah belajar tadi, using neutralization reaction, titration methods. Okay, kita titratekan acid ke dalam alkali using titration methods. Other than those salts, selain daripada anak salts, kalau dia soluble, we have to use another ways. Dan kita akan tengok in our next class. Okay, if you already write down the name of the salts in the chat box, you will get the participation marks, and then that marks the end of our class today. There are no exercise for today, but I hope you can do some revision on your own and complete homework yang saya dah bagi yang awak tak buat lagi. You can still hand it in, but notify me so that I can saya tahu yang awak dah hantar. Kalau tak, nanti saya tak record awak hantar. Alright, so take this time untuk tengok everything. Try untuk tengok juga the next our next lesson. And then kalau dah tulis dekat dalam chat box, you may later Google me, and I will see you next class. Thank you very much.
Thank you, teacher.
Thank you, teacher.
Welcome.
Yeah.
Make sure tulis ya apa salt. Kalau tak tulis tak dapat marks.
Teacher,
Yes.
yang pasal lead to chloride dengan lead to iodide tadi kan insoluble.
Yes.
Maksudnya kalau dia nak soluble tu mesti ada head lah kan?
Mesti